Good afternoon, students.
Dear students, good afternoon to all. Today, we are going to discuss about early Weinberg principle and the origin and evolution of the man. This is a subtopic of chapter 6, evolution. In nature, populations are usually evolving, such as grazing and open meadows, wolves in a forest, and bacteria in a person's body. These all are natural populations. All of these populations are evolving some of their genes. Evolution does not mean that the population is moving towards perfection. The evolution does not mean that the population is moving towards the perfection. Rather than the population is changing its genetic makeup over generation. For example, wolf population in the forest. There may be a shift in the frequency of a gene, variant for black fur than gray fur. Sometimes this type of the change is due to natural selection or due to migration or due to random events. First, we will see the set of conditions required for a population not to evolve. So these characteristics, these conditions, we are going to discuss under early Weinberg principle. Early Weinberg law was proposed by Hardy and Weinberg in 1908. Hardy came from UK and Weinberg came from Germany in 1908. So this law was called Hardy Weinberg law because the Hardy and Weinberg proposed this law. So this law was called Hardy Weinberg principle or Hardy Weinberg law. This law stated gene frequency, or we can say the allele frequency of various genes of a population remain constant generation after generation. This law states that gene frequency of various genes of a population remain constant generation after generation. So the early Weinberg law starts that gene frequency of various genes of a population remain constant generation after generation when the population is large mating is at a random. Random is not equal. Random is not equal. In the axis of the mutation and genetic drift and selection and migration. So these are the characteristics not takes place in the population like that Hardy and Weinberg explained that here. When the gene frequency remains constant, you already know what is gene and what is the gene frequency. Frequency means number of the genes which are present in the population is called gene frequency. You understand? You know very well about gene. You know very well about the allele. So you know about the name of the what is allelomorph. So gene frequency means the number of the genes which are present in the population is they are mentioning like a gene frequency. The gene frequency remains constant generation after generation. The population is genetic equilibrium. The population is, you can say, genetic equilibrium or otherwise known as Hardy Weinberg equilibrium. So it is another name for the genetic equilibrium or Hardy Weinberg equilibrium. So they will ask the question like that, what is the other name for the Hardy Weinberg equilibrium? Sometimes they will ask the question, define the genetic equilibrium. So what is genetic equilibrium means? The gene frequency remains constant generation after generation. There is no change at all. So that type of the population is genetic equilibrium or otherwise known as the Hardy Weinberg equilibrium. I think you understand. When the population is in genetic equilibrium, the rate of evolution is 0. So remember this one. This is one of the big questions. When the population in a genetic equilibrium, that means there is no change at all. Only the generation after generation, the remaining frequency is present there. The rate of evolution is 0. There is no evolutionary changes. So the evolution is 0 whenever the genetic equilibrium is maintaining in the population. Okay. Next, Hartley Weinberg law. The population will not undergo evolution. Hartley and Weinberg explained in their law the population will not undergo evolution because they said so there is a no evolution, sorry, there is a no mutation, no genetic drift and migration. Anything is not takes place in that particular population. Like that they explained. So the Hartley-Weinberg law, the population will not undergo evolution. So the evolution occurs only when the Hartley-Weinberg equilibrium is altered. Suppose any changes are explained in Hartley-Weinberg equilibrium, in that time the evolution can take place. Otherwise, there is no evolutionary changes are takes place in the Hartley-Weinberg according to the Hartley-Weinberg principles in the population. That means there is no change in the population according to only Hartley-Weinberg. So there is no changes in the population because there is does not take place the mutation, migration, and genetic drift anything. So the Hartley-Weinberg law is represented by one formula that is called P plus Q. P plus Q equal 1. That is a law or formula of the Hartley-Weinberg principle. So what is P? P is the frequency of dominant gene in a population. P is a frequency of dominant gene. Only it is a dominant gene in a given population. So the Q is a frequency of recessive gene. It is a recessive gene in a given population. So okay, now what is 1? The 1 is the total of all allelic frequency. Total of all allelic frequency. Total is otherwise called the sum. So the 1 is the total of all allelic frequency. This formula is used to find out the frequency of dominant gene and the recessive gene in a population. For example, in one population, there is a dominant gene also present and a recessive gene also present. So we want to find out what is the dominant character. So how many numbers are dominant character? How many genes are equaling with the recessive character? That we are studied under this formula. That is P plus Q equal 1. This formula was given by Hartley and Weinberg. The frequency of heterozygotes and homozygotes in a population can be calculated by another one type of the formula that is also given by Hartley-Weinberg, that is called P plus Q whole square equal P square plus 2PQ plus Q square. And with the help of this formula, they explain about the frequency of the heterozygotes as well as the homozygotes. For example, like that AA allele is present, that is called the homozygous dominant. Like this AA allele is present, that is called the homozygous recessive. Suppose AA allele like that present, that is called the heterozygous dominant. Heterozygous dominant. So the frequency of heterozygotes and homozygotes in a population can be calculated by the one of the law or formula that is P plus Q whole square equal P square plus 2PQ plus Q square. So next one. First, what is P? What is P? P is the frequency of dominant gene. P is the frequency of dominant gene. Q is a frequency of recessive gene. The P is a frequency of the dominant. Frequency means I already told you. The frequency means that is called the number of the frequency means that is called the number of the genes present in the particular population. P is the frequency of the dominant gene. Q is the frequency of recessive gene. P square is the frequency of dominant homozygote. And 2PQ is the frequency of heterozygote. And Q square equal frequency of recessive homozygote. You understand? It's a very important formula. Under this formula, definitely one question will come from the NEET exam. Okay, so they will ask definitely one question. So you remember it. very important formula given by the early Weinberg. So this is one of the important thing in our evolution. So that formula is that p plus 2 equal to 1 or p plus 2 whole square equal to p square plus 2pq plus q square. So the early Weinberg law says that foundation for the study of population genetics. So they explain only about the population. So what is really population genetics? Studying about the genetics about the population. That is called the population genetics. The population genetics was given by the or explained by the Hartley and Weinberg. It gives the mathematical approach for genetics as well as the evolution. They given the mathematical approach for the genetics as well as the evolution. Now we are going to see application of the Hartley Weinberg law. You know what is Hartley Weinberg law? When the gene frequency remains constant, generation after generation, the population is known as called in the genetic equilibrium or Hartley Weinberg equilibrium. So under the Hartley Weinberg equilibrium, we are read about the all the gene frequency remain constant generation after generation. There is no change at all because there are not at all getting any mutation or anything is not takes place in the population. So now we are going to discuss about application of Hartley Weinberg law. First one, Hartley Weinberg law has two main applications. That is very important one. How many applications are getting from the Hartley Weinberg law? Two main applications. First application, calculation of the frequency of the recessive gene as well as the dominant gene in the population. So one population we are taking means there is a dominant character also present. That are represented by the dominant gene. The recessive characters are represented by the recessive gene. So these are calculated with the help of the Hartley Weinberg equilibrium. Second, it is helpful for the calculation of the heterozygotes in a population. You know what is homozygous? What is heterozygous? Homozygous means both alleles are present in the dominant gene. So the heterozygous means both alleles are present. The dominant allele as well as the recessive alleles are present. So that is called the heterozygous. For example, like this. Dominant means that is represented by the. So these are calculated with the help of the Hartley Weinberg law. We can take one example. That is a beetle. We have a large population of the beetles. We are taking the one example. Help of the beetle population. They appear in two colors. We can see the two colors of the beetles. One is the dark gray. One is the dark gray. Another one is the light gray. Dark gray we can mention like a black. Light gray, okay, we can give the gray color. One color is a black and another one color is a gray. Both the beetles are present in the one single population. For example, like this. So, for example, you can take like this. So we are taking like this one population. In that population, that is a beetle population. You can imagine it like this. So one gene is a dominant gene. So that represents the black one. So that is we can represent like a H. So some genes are like a recessive that represent the gray color. So like that, number of the genes are present in the same population. Number of the genes are present in the same population. So the first, the dark color is a black. So we can say that is a dark gray. In your book, they given in the bracket that is a dark gray color. The dark gray color is we are taking black color. And another one is a light gray. That is a gray color. Color is determined by the age. These colors only determined by the age determining the color. So the age is determining the dark color and the recessive gene determining the gray color. Gray color. That is light color. Okay. So now let us assume a beetle population containing 1000 individuals of this. So we are taking like this. Here 1000 individuals of the species are present in the beetle population. Out of 1000, 700 individuals are dark green. 700 individuals are dark green. Out of 1000, 300 individuals are gray in color. 300 individuals are gray in color. So these individuals can be homozygous dominant as well as what? Heterozygous dominant. This dark color mentioning homozygous dominant or heterozygous dominant. That is two type of the individuals cannot be identical or identified externally. That is a two type of the genes are present like that dominant gene, dominant character and like this. This is homozygous dominant, this is heterozygous dominant. Both also present in the particular population. But the two type of these individuals cannot be identified externally. By applying the Arley-Weinberg formula, the frequency of dominant A and recessive gene, frequency of dominant and recessive genes can be calculated. Similarly, the heterozygous individual can be calculated. This also we can calculate, this also we can calculate, this also we can calculate with the help of the Arley-Weinberg formula. Now, total population is how much? 1000. Okay. What is the dark gray color? 700. Okay. What is the light gray color? 300. Okay. So this 300 is mentioned by the gene recessive gene. 700 is mentioned by the dominant gene as well as the heterozygous dominant. Okay. What is the frequency of black color? Already black color is 700 and the gray color is 300. So total population is 1000. So what is the frequency of black color? Like the they will ask the question in the name. So out of 7,000, how many black color? 700. So frequency is 700 is divided by the 1000. So the frequency is 0.7. So 0.7. What is the frequency of light gray? 300 by 1000. Let this we want to once again. 300 is divided by 1000. So that is a frequency is 0.3. So they will ask the question, what is the frequency? Frequency means, so we want to divide the number of the gene and divided by the total number of the. So let the frequency of the A gene is, we are mentioning like a P. So the A gene is mentioning like that. I already told you. Let the frequency of A gene is what? The frequency of recessive gene is Q. That means dominant gene is we are mentioning like a Q, and the recessive gene is we are mentioning like a Q. So apply this Arley-Weinberg formula. P plus Q whole square equal to, we already know about the formula of the Arley-Weinberg. P square equal to P square plus 2PQ plus Q square. Okay. So now we are substituting the numbers here. P square already we know P equal, that is a dominant A. So 0.7 square plus 2P 0.7 Q 0.3 plus Q square 0.3 whole square. Like that we want to switch. So 0.7 square equal 0.49. 2 into 0.7 into 0.3 will give the 0.42 plus 0.09. So now 0.49 dominant, that is a totally homozygous term. 0.42 is a heterozygous dominant because both type of the alleles. 0.09 is the homozygous recessive. Now we are making the percentage. 0.49, we are taking the percentage is 49%. And another one is the 42%. And the recessive character is 9%. So the frequency of the heterozygous in the population is 42. Heterozygous is 42 and homozygous is 49 and homozygous recessive is 9.9%. So out of 1000 individuals, how many individuals are? So they will find out the frequency. Now they will ask a question like this. So how many individuals? So number of the individuals they will ask. So that time 490 individuals are homozygous dominant. 420 individuals are heterozygous dominant. 90 individuals are homozygous recessive. So the frequency of A, that is dominant, as well as the recessive genes calculated as follows: P plus 2 equal 1. We know already what is P. We know already what is P. And 1 is the total number of the allelic frequency. So P is the 0.7 plus 2 is the 0.3. So equal 1. That means 1 equal 1. So now we can see the beetle population. The beetle population assumes that the frequency of dominantly as well as the recessively in the pool of candidates. The pool means there is a gene pool. Pool means what? Gene pool. Total number of the population present in the particular place. That is called the pool of candidates. That make the next generation would be the same. There is a no variation of all. So the argument is we under the argument we are understanding there is no variations that takes place in the particular population because there is only the random mating only takes place. There is no mutation, there is no genetic difference takes place. So only the population is remain constant. So that is a oddly weighted equilibrium. So next we are going to see what is gene pool. So number of the times we told. So what is gene pool? The total number of the genes present in the particular population is known as the gene pool. So that are making like that we can read number of the genes present in the population. See like this. Number of the genes present in the population. The genes are making interaction or interbreeding each other. That are making. Like that, we are making the interbreeding all genes. So gene pool, the total genes that are the sum of the total genes that are the Mendelian population, it includes all the genes of the individuals of a population. The sum total genes present in a Mendelian population. This includes all the genes of all individuals of a population. That is one of the definition. They will ask in the 2 mark question. Define the gene pool. So note it this one. The sum total of genes present in a population. In one particular place or in a particular population. So how many number of the genes are present? The total only we are saying the gene pool. So the gene pool of each population is maintaining its integrity, maintaining the integrity as long as there is a no interbreeding between the population. So this is here one of the gene pool. Next, what is gene pool? The transfer of genes from one gene pool to the another is called gene flow. So like that we can take one. Like that we are taking the one population. That means one gene pool. So another one is the separate gene pool. So these are transferring the genes from one gene pool to the another gene pool and forming the new gene pool. Group of the genes. That is known as the gene flow. You understand? The transfer of genes from one gene pool to another is called the gene pool. The gene, for example, we are taking the gene pool A and another one is the gene pool B. So the both also making the interbreeding. So you know what is interbreeding? That is it takes place the breeding between the A gene pool and the B gene. So now that some genes are coming from the A and some genes are coming from the B and they make the other one new gene. So that is called the gene flow. The character is known as the gene flow. The gene flow leads to the mixing and reshuffling of the genes. That means we can see the 2 kinds of the genes. The third one, the third gene pool. So that is what the mixing and reshuffling can take place because of the help of the gene flow. You know what is gene? So number of the genes present in the particular population is known as the gene pool. So the genes are moving from the one gene pool to the another gene pool, or from the 2 or 3 gene pool, and making the one new that is what gene pool means. That is called that transfer of the genes only known as the gene flow. Early Weinberg assumption. Before the early Weinberg assumption, we want to know about another one, 2 marks. What is gene frequency? The gene frequency means the ratio of the one allele to another allele in a gene pool or a population is called gene frequency. Without mistake, you want to write the definition. They will ask the person like what is define the gene pool, define the gene flow, and define the gene frequency, and define the early Weinberg. You understand? Gene frequency means the ratio of the one allele to the another allele in a gene pool or a population is called gene frequency. What is gene flow? They will ask the question is the transfer of the genes from one gene pool to the another is called the gene flow. What is gene pool? Like that they will ask the question is the sum or total of genes present in a population. And given a Mendelian population. So what is the simple meaning for gene pool? The sum means total. The total of genes present in a population is called the gene. Simply you can remember it. What is gene pool? The total of genes present in the population is known as the gene. Okay, what is gene flow? Transfer of the genes from one gene pool to the another is called the gene flow. What is given gene frequency? The ratio of the one allele to another allele in a gene pool or a population is called gene frequency. So now next we are going to see early Weinberg assumption. Early Weinberg assumption. First one, under the first early Weinberg assumption. First one, we are thinking about the early Weinberg assumption. First, no mutations. No new alleles are generated. No new alleles are generated, or that means no new alleles are formed by the mutation, or after making the duplication or deletion. So first early Weinberg assumption. Under that one, first point, that is a no mutation. Mutation means sudden change. The sudden change is not allowed takes place in the population. First one, no new alleles are generated by mutation. You know what is mutation? Sudden changes takes place in the any case or in the population is called a mutation. Now the genes are get duplicated. No duplication can happen. They are not deleted. So any changes that takes place in the population. That is one of the assumptions by early Weinberg. Second one, random mating. Early Weinberg EPV is maintained only when the mating is a population is at random. Random is not equal. You want to write that. Random is what? Not equal. No preference for a particular genotype. They are not giving the preference for the particular genotype. Third one, no gene flow. Neither the individuals nor the gametes enter or exist. Any individuals cannot enter or does not enter or exist from the population. So the enter means that is we can say the immigration. Exist means we can see the immigration. The fourth one, no gene flow. Neither the individuals nor the gametes enter or exist here in the population. Next, very large population size. The population should be infinity in size because there is no gene flow, no genetic difference, no mutation. The populations are making, the genes are making only the random mating. So the population should be infinity in size. So next one, no natural selection also. All alleles are fit in the survival because the new genes are not entering in. Any genes are not at all moving from the population, one population to the other. So the alleles are fit to survive and reproduce. If any one of these assumptions were not met, the population will not be in early Weinberg because early and Weinberg explained. So there is no changes that takes place in population. Only what are the genes already present in the population? The genes only making, interpreting, and producing the new population there. So the new another population or another genes does not enter in the inside of the another population. That means if any one of these assumptions were not made, the population will not be in the organized unit. Only if the all allele frequency changes from one generation to the another, the evolution will be takes place. Suppose any changes are takes place in the particular population, the evolution that takes place. Otherwise, so there is no new populations or there is no chance or choice to produce the new population. Like the RB and Weinberg explained there. That means conclusion of the RD equilibrium we can understand. So the populations always maintaining the same frequency because there is does not take place the mutation, genetic drift, and any other changes, sudden changes. So the population genes are from one population to another population. That's not they are taking randomly, they are making and producing the same type of the alleles in a particular population. So that is a RD. So under this equilibrium, under the formula P plus 2 equal 1, in the NEET exam, they will ask the number of the questions. Definitely one sum will come from the arguments, but okay. Next, we are going to discuss about the origin and evolution of the plant. Human evolution states that humans developed from the primates. The monkey varieties are coming under the primates or ape-like ancestors. There are 4 main stages in the origin of the man. One is ape, second one is the ape man, third one is the primitive man, and the fourth one is the modern man. See, these are not given in your book. So, we need to observe the class and see the video and read all the points because the origin and the evolution of man under the given the points all are the important for the NEET exam. So, we can. First one, ape stage. Under the ape stage, the ancestors of man was primitive ape, which are lived. They were lived 30 million years ago. These apes are primates, like a monkeys. The primates are ancestral ape of Dryopithecus. They are Dryopithecus. They are Dryopithecus. The first, the main stage of the origin of the man is divided or classified into 4 types. First type is the ape, second type ape man, third type primitive man, and fourth type modern man. Under the ape stage, the ancestor of man was primitive ape, which lived 30 million years ago. The apes are primates. The primitive ancestral ape was Dryopithecus. Here, Dryopithecus. The Dryopithecus characteristics. They will ask 2 more questions. Write about the characteristic of the Dryopithecus. Dryopithecus. They were lived 15 Maya. MYA means million years ago. You want to read like that. 15 million years ago, they lived in the world. Only we can see their fossils. So, these fossils are discovered from rocks of Africa and Europe. Number of the points not given in your book. For the NEET preparation only, I have given these points. So, we note down these points afterwards. Okay, the Dryopithecus are vegetarians. They were only ate fruits. So, fruit eater. Next, body is fully covered by the hair, so the body is hairy body. This is the first type of first stage of the man. The man is originated from the lower stage to upper stage. No. So, we are classifying the origin of man by the 4 stages. First stage only ape. Second stage called ape man stage. It is a second step in the origin of man. It includes Rampithecus and Australopithecus. See in the diagram. These are called the Rampithecus. This type of the man are called the Australopithecus. So with the picture also you can understand the characteristic of the things. Rampithecus. First man-like primate. These are first man-like primate. Body is covered by hair, so only hairy body. walked like apes. These are walked like apes, like a gorilla and chimpanzees. They were present in East Africa. These are one word for needed. Ethiopia and Tanzania. They were lived 15 million years ago. This is also one of the related questions. They will give they will ask this question in the match the following also. Or which pair is wrong, which pair is right, like that also they will ask the question. So you want to memorize these characteristics. Okay, so next, height. They were 4 feet. Next, they were discovered from Shivalik hills. They were discovered from Shivalik hills. They were discovered from Shivalik hills. Next, Shivapithecus. That is Shivapithecus or sagebrush. So the important one, Shivapithecus are also coming under the sagebrush. That is a rampithecus. See, the second stage of man is the caveman stage. The caveman stage has here 2 types. One is the rampithecus, another one is the australopithecus. The rampithecus are the Shivapithecus also coming under the rampithecus. Third one, australopithecus. Third one is the australopithecus. They were lived in East Africa grassland. This is australopithecus. They were lived in East African grassland. They used to hunt with stone. They used that means they used the stone for hunting. They ate only fruits. So we can say they were the fruit eaters. Next, they were first ape man. They were first ape man. They were the first ape man. Called, it is one of the fossil. The australopithecus are we explained or we discovered about the australopithecus with the help of the fossil. That swan fossil only known as swan baby. The swan baby fossil was discovered by the Raymond Dart. And another one fossil they discovered, that is a Lucy during the australopithecus period. That is a Lucy by Donald Johnson. So important 2 words, remember it, swan baby and Lucy. These are the fossils of the australopithecus. You understand? Swan baby was the fossils of the australopithecus. Lucy also one of the fossils of the australopithecus. The swan baby was discovered by the Raymond Dart. Lucy was discovered by the Donald Johnson. So these australopithecus connecting link between the apes and primitive man. Apes as well as the primitive man. This is one important question. Which is a connecting link between the ape and the primitive man. Australopithecus was the link between the ape and the primitive man. Connecting link. You already studied about the connecting link in the birds. So like that, which is a connecting link between the ape and primitive man. So the connecting link between the ape and primitive man is Australopithecus. Next one. Their eyebrows, the Australopithecus eyebrows, the Australopithecus eyebrows. Next, we can see about the primitive. So that is the third stage, primitive man. First stage, ape man. Second one on the ape man stage. Next, third one is the primitive man. Primitive men are prehistoric men. Primitive men are prehistoric men. Primitive men are the prehistoric men. They were first true men. So this is one of the interesting. First true man was primitive. They form connecting link between Australopithecus and modern man. Modern one connecting link is I told. That is a connecting link between the ape and primitive man is the Australopithecus. Now the connecting link between the Australopithecus and modern man is the primitive man. So they buried the dead bodies And the following are the important primitive man. First one, Homo habilis. Second one, Homo erectus. And third is the Neanderthal man. So you want to remember everything because it's somewhat hard. But anyway, you want to remember words. It's very important, no? So, Homo habilis. The Homo habilis was first human like being. They were tool maker and skill man. And first they used the hand. So what they were called the hand man. So remember it. The number of the questions are there. First human like being, who was called the first human like being, Homo habilis. Who was the tool maker? Homo habilis. Who was the skill man? Homo habilis. Who was the hand man? Homo habilis. Like that, the number of the questions they can ask. Discovered by the, this was discovered by the lady from India. The place name also you want to remember. Cranial capacity. In the time, the brain capacity was 6050 to 800 cc. Cranial capacity. Cc means cranial capacity. The cranial capacity they will ask under the that's the following. So you want to remember all the cranial capacity of the all the that is what that is a primitive man's cranial capacity. Next one, Homo erectus. Homo erectus are the Java man. Another one word. Who was the Java man? Homo erectus was the Java man because discovered from the Java. Next, here existed. Existed means lived. Existed means lived in 1.5 million years ago. Maya means million years ago. Million of the years ago. Big head. They were meat eater. They were begging man, teaching man, like that you want to pronounce it. Because they discovered this one in China. The China capital was Beijing. The Beijing only like that called begging man. It's a teaching man. Homo erectus was the teaching man. Very important one. Cranial capacity was 900 cc. That is cranial capacity. So next one. Neanderthal man. Next, Neanderthal man. So, they were advanced primitive man. They were advanced primitive man. They were advanced primitive. They lived in Europe. The place in what? They lived in Europe. Neanderthal man are advanced primitive man. They lived in Europe. So next, the eyebrow are very rich. They are used to wear the tough skins of the animals. They wear like a cloth, tough skin of the animals. They lived 1 lakh to 40,000 years. Buried their dead ones. The fossils are recovered from the Neanderthal valley. Fossils are recovered from the Neanderthal valley in Germany. Cranial capacity was 1400 cc. Cranial capacity was 1400 cc. These are the characteristics of the Neanderthal. So they will ask the question like that. So what are the characteristics of the Homo habilis? What are the characteristics of the Homo erectus? And what are the characteristics of the Neanderthal man? So next one, Cro-Magnon man. That is a Homo sapien fossils. Cro-Magnon man. That is a Homo sapien fossils. The Homo erectus, I already told you Homo erectus about Homo erectus. The Homo erectus are first human-like beings, and they lived in 1.7 million years ago. They first lived African continent. That one word answer. So then they lived from the Africa because most of the all the rest of the human beings are evolved in Africa. So then they came from the Africa and moved to the other countries. So the first fifth African continent, that was Homo erectus. That is one of the one word. So next one, we are going to see about the Cro-Magnon. Under the primitive man, Homo habilis, Homo erectus, Neanderthal man. Three. Next, Cro-Magnon. The Cro-Magnon man are Homo sapiens fossils. So remember that one. Cro-Magnon man are the Homo sapiens fossils. The Cro-Magnon man was extinct modern man. The fossils discovered from Cro-Magnon man's rocks of France. Remember the name. They were originated from 34,000 years ago. They were recent ancestors of the modern man. They were run faster. They lived in the caves. They were the omnivores. Their cranial capacity was 1650 cc. So these are the characteristics of the Cro-Magnon man. Cro-Magnon man only they were Homo sapiens fossils. They were called the extinct modern man. They discovered the fossils from France. They were run faster. They were lived in caves. Cranial capacity was 1650 cc. Next, modern man, the last type, modern man. First, ape man, and the third one is the primitive man, and the fourth one is the modern. It includes all the existing man and some existing extinct man. Existing man and the extinct man. So remember that one, all the modern man include all the extinct man as well as the existing man. They appeared 3 million years ago. They originated in Asia and Caspian Sea. Remember that one? The modern man originated in Asia and Caspian Sea. The primitive man only evolved from Africa. So, but the modern man originated in Asia and Caspian Sea. The modern man belonged to the species Homo sapiens. That is a zoological term for the man. The skull is rounded in shape. Cranial capacity 1400 cc. Remember, 1400 cc. Very important one. The cranial capacity of the modern man. So now we are all modern man. So our cranial capacity is 1400 cc. Arose in Africa. They were arose in Africa. So, but the arose in Africa means first they have started the life in Africa, but originated in the Asia and Caspian Sea. So the arose in Africa some 45,000 years ago. They evolved around 75,000 to 10,000 years ago during Ice Age. The Ice Age is 75,000 to 10,000 years of the Ice Age. Prehistoric cave art developed 18,000 years ago. These are important one verse. Agriculture and human settlement started 10,000 years ago. First agriculture and human settlement started 10,000 years ago. They were omnivorous type. That is, all the Homo sapiens are omnivorous type. Human evolving is example for the adaptive radiation. You already studied about the adaptive radiation. According to the environmental condition, the organism can develop their characters and make it suitable for their environment. That is called the adaptive radiation. That character is very high developed in the modern. Increasing the cranial capacity and loss of pain. These are the significant change from ape to man. Very important point. Increasing the cranial capacity. So already we have the cranial capacity 1400 cc. The cranial capacity can increase or loss of the tail. The tail is absent in the human being. So there is a significant change from ape to man. The Homo sapien has a distinct species from apes to placental mammals. The mammals which are having the placenta, that means connection between the child and baby, that is called the placenta. So the Homo sapien has a distinct species from apes and placental mammals in brain size and other behavior rules. Androgyny recapitulate phylogeny. Androgyny recapitulate phylogeny. So these are the characteristics of the modern man. These are the characteristics of the modern man. Like that, now human beings evolved in the world or originated in the world. So that is given by the four topics. That is in Vietnam, and so that's one ape like man is primitive man, and the fourth one modern man. Okay, we understand? Shall I ask the question? Shall I ask the question, ma? Question. So listen, ma. Today we discussed about the origin of equilibrium as well as the origin of the human evolution. Okay. If you have any doubt, you can ask me now.
Hello.
Can you understand? Hello. If you have any doubt, you can ask me, ma.
Swati, did you understand?
MST. Can you hear my voice?
Chemistry?
Yes, ma'am.
Yes, ma'am.
Say loudly. Can you hear my voice?
Yes, ma'am. Now I am here.
Oh, okay. Sorry, ma. The fan sound, so I can't hear your voice. So, do you understand?